Okay, in this video we're going to take a look at arithmetic sequences. So a sequence is simply a list of numbers. And if that list increases or decreases by the same amount between each term, each number, then it's called arithmetic. So for example, if we take 2 and 7, that goes up by 5. So if we go up by 5 more and up by 5 more, and we continue that pattern of plus 5 each step, then that would be arithmetic. If you took a list like 1 and 2, that goes up by 1, and then went up by something that isn't 1, there's still a pattern to this. This looks like it goes up by 1, up by 2, up by 3, up by 4. That's a sequence, but it's not an arithmetic sequence. Now there's some terminology with these arithmetic sequences. So the very first term of an arithmetic sequence, that term has a special name or symbol or letter, which is, it's called the first term, and the letter that we associate with it is the letter A. And then if we have an arithmetic sequence, then you'll have a number that you'll go up and down with each time. In this case, it's the plus 5. That's known as the common difference. So it's up by 5, up by 5, up by 5, or down by 2, down by 2, down by 2. That value is known as the common difference and is associated with the letter D. So for example, just give a little more space here. If I had 2, 7, 12, 17 like I did before, that has that A value of 2 and the D value is 5. And if I had an example like 5, negative 20, negative 45, negative 70, that has an A value of 5, and the difference is this goes down by 25 and this goes down by 25, so this D is negative 25. Now, once you know the A value and the D value, you can just build this sequence. You can just keep writing them out as long as you want. But there is a quicker way. For instance, if we want to find the 10th or 20th or 30th term in a sequence, there's a way of just starting with A and adding D and adding D and adding D. But it gets a little tricky if you want to find a really high number in the sequence. So we've got some formulas that'll help us do that. So to find a certain term in the sequence, and we use t with a little n next to it to say which term we're dealing with. So this would be term number 1, and this would be term number 2, and this would be term number 3, and this would be term number 4. And somewhere down this list would be term number n, which would be the nth term. So to find that nth term in a sequence, we would start at A and add D however many times, n times, to find that. So let's take a look at another list, another sequence, and try to solve one of these problems. So given the sequence 2, 6, 10, 14, and onwards, let's see if we can figure out what the 50th term is. So yeah, you can start by saying, okay, T1, this one, or we call it A, is this one, and then you got T2 and T3, and you could list out that's T4. You could list out all the way to the 50th term, but it's going to take you a long time to do that. So there's got to be a little bit of a quicker way. And let's just double check. We know that A is 2. Let's just double check that this is actually arithmetic. Up by 4, up by 4, up by 4. So the D is 4. So yes, arithmetic. And we do need to check that because later in this unit we're going to see different kinds of these sequences, and if they're not arithmetic, then we're going to use other ways to solve these problems. So the question is, how many times, if we start at A, how many times do we add D to get to the 50th term? And we add D once, we're at the second term. We add D twice, we're at the third term. So I think we need to add 49 Ds to get to that 50th term. So we start at 2, we add D 49 more times, and D was 4, and we should end up at the 50th term, and that 50th term would therefore be equal to 198 simply by doing a quick calculation rather than having to list this whole thing out. And what I really did here is I found the nth term by taking the first term and adding D multiplied by something. And the thing that I multiplied by was 49 in this case. So to find the 50th term, this is n is 50, I actually used one less. So I added d one less than the number of terms that I have. And the reason it's one less is I don't need to add it for that first term. So I add it once, twice, 3 times for the fourth term, so 49 times for the 50th term. This formula here is key to being able to do these sorts of questions. This is the general formula for finding the nth term, the value of the nth term. If you know the first term, the common difference, and you also know how many terms. One of the things that I see students getting most confused with is Tn and n. A and D seems to be pretty obvious. You have a first term and you have a common difference. The difference between Tn and n is how many terms you have, and Tn is the value of that 50th or 10th or third term. Let's take a look at a couple more examples. Okay, let's find the 107th term if you start at 81 and then you have 75 and then you have 69. So obviously you don't want to list out all 107 terms. So let's see if we can figure out using this formula what the value of that term is. So is this arithmetic? That's our first thing to look for, and I detect that by seeing, do I go up or down the same amount each time? So it looks like I do, and I automatically know my d value from checking if it's arithmetic, and I know my a value, and this part here is my n value, so n is 107. And now I can go and figure out what T107 is. What's the value of that 107th term in my list? So it's 81 plus 107 take away 1, and the common difference is -6. So grab your calculator and actually make sure you can punch this in properly. You should pause the video right now and do this. You should get this huge number of -51,516. Of course, if you just used a calculator, you would know I'm wrong, and it's actually -555, and now you have the 107th term. We can ask questions to do with sequences in other ways as well. Still using this formula, you can solve for other parts of it. So you might see a question like this next one. Which term of this arithmetic sequence has a value of 811? So here's 11, 23.5, 36. Again, we can calculate the d value simply by seeing what do we add. And in this case, we're adding 12.5. You know your a value is 11. And now instead of solving for what's the value of the nth term, I know the value of the nth term, and I don't know n, which term number, Tn, what's this number down here? Not the value, the number is what I'm looking for. Okay, so with our formula, we've got T sub n is equal to a plus n minus 1 times d, and I know the value of that term is 811. So the first term is 11, I don't know how many terms to count, and a common difference of 12.5. And this is a little bit of algebra to solve this, so I could subtract 11 on both sides, I get 800, and then distribute this part, I get 12.5n minus 12.5. I add 12.5 to both sides. 812.5 is 12.5n, and divide both sides by 12.5. Probably need a calculator to do this, and you will get n is 65. So that tells you that we are dealing with the 65th term of 811. So which term? It's the 65th term that has that value of 811. So again, this is the value and this is the term number, like how many terms are we counting along our list. Okay, one more to go and a little bit of a different approach for this one. So again, we've got an arithmetic sequence. The 8th term is 21 and the 12th term is 15, and we want to find the very first term. So I like to set these sorts of questions up, instead of using formulas that are given, I just use a little bit of common sense. So here's the first term, here's the second term, this is A. Third term, fourth, fifth, sixth, seventh, and this is the 8th term, and it's worth 21. 9th term, 10th term, 11th term, 12th term, and that's worth 15. And so let's take a look at this. If you add D, and add D, and add D, and add D, so that's 1, 2, 3, 4. If I take 21 and I add D 4 times, I would end up at 15. So if I subtract 21 and subtract 21, 4D is negative 6. Divide by 4, divide by 4, D is negative 1.5. So that's good. This is going down, down by 1.5, down by 1.5, down by 1.5, down by 1.5. But now I could use some information like the 8th term is 21, and here's the common difference with my formula. So Tn is A plus n minus 1 times D. Or you could just subtract the common difference and go backwards, but I think now using a formula once I have my D value is going to be very good. So the 8th term, T8, is 21. I don't know the A value. I do know the N. N is 8. And the common difference is negative 1.5. And this time I'm solving for this A value. So I have 21 equals A plus 7 times negative 1.5. Probably want a calculator to do 7 times 1.5. That'll be a negative number. Negative 10.5. And add 10.5, you'll get 31.5. And so this very first term will be 31.5. So there is a strategy just to listing a series of numbers out and looking and using the idea of common difference as well as using these formulas. I find this to be the fastest way to do these sorts of questions. Okay, we'll see you in class.